Hello. Today we're going to talk about balancing chemical equations. So the first thing you need to know is there's this thing called the law of conservation of mass. So in anything in life, however much mass you start with, you have to end with the same amount of mass. So for example, if you have like a campfire, the mass, however much your wood weighs before you start the fire, is going to weigh the same as after you burn the fire away. Problem is that you'd have to capture all of the gases and everything that's released while burning that fire. But if you manage to, all of that and the ash from the wood would weigh the same as the wood that you started with. So it's kind of a crazy thought. That is the law of conservation of mass. When we're talking about balancing equations, we're really more talking about the number of atoms that I start with. I have to end with the same number of atoms. Okay, so let's look at an example. So I have this compound here, KiO3, and then I have the arrow. So anything before the arrow is called a reactant. So I have one reactant in this formula. I have my one compound here, KiO3. That's my reactant. And then I have the arrow, and anything after the arrow are called products. So I have one compound that's a product, and then I have one element that's a product. This is considered an element and not a compound because it's just oxygen. It's just one element. So even though there are two oxygens stuck together, it's still considered an element. Okay, so as a products, I have one compound, Ki, and I have one element, and they are separate. So something that I think gets people stuck sometimes is they look at this too much like a plus sign. Think of it more as an and. So I have this compound reacts to form Ki and oxygen. Okay, it's not that these two are going to be added together. It's that those are the two separate things I end with, Ki and oxygen. So I think it helps to kind of think about it that way. All right, so here's my issue. Whatever I start with, I have to end with the same number. Okay, so the easiest way to start is to make this reactants products chart. You'll get to a point where you don't need it, but it's a good place to start while we're just beginning. Okay, so let's keep track. How many K's did I start with? How many I's did I start with? How many O's did I start with? So again, just looking at the reactants means I'm looking at everything before the arrow. So I need to figure out how many K's I have. Now to figure out how much of an element you have, you look in two places. You look in front of the compound. Okay, sometimes there's a big number out in front, which is called a coefficient. And then you'll also look right here next to it, just like you see with this O, okay, to see if there's a subscript. So for K, there's no big number in front, and there's no little number. So that means that there is one K. Then I go to I, and I do the same thing. No big number, no subscript, no coefficient, no subscript. So that means there's one I. Okay, and then I go to O. Look in front, there's no coefficient here, but there's 3 here. So you say 1 times 3. So I have 3 oxygens. Okay? So that's what I'm starting with for reactants. 1 potassium, 1 iodine, and 1 oxygen. Then I move on to the products, so everything after the arrow. And I know they have to be the same. It has to be a K, an I, and an O, because whatever I start with, I have to end with. So moving on to K, make sure you look in all of the products, since I do have multiple things going on in this equation. Okay, so check all the products, everything after the arrow. So here's the only K I see. I do the same thing. No coefficient, no subscript. That means there's one potassium. Do the same thing for iodine, no coefficient, no subscript, means there's 1 iodine. And then I move on to oxygen. No coefficient, that means it's a 1. It does have a subscript of 2, so 1 times 2. I have 2 oxygens to end with. All right, so this is how we set up our chart. And then in an ideal perfect situation, all of these numbers match. So here they do match. I have 1 potassium to start with, and I have 1 potassium to end with. That is perfect. That's exactly what I want to see. I need to see the number of potassiums I start with match the number of potassiums I end with. And I do. So I'm good here. Move on. I'm starting with 1 iodine, 1 atom of iodine, and I'm ending with 1 atom of iodine. How nice. Perfect. Move on to the next one, and I have an issue. Okay, I'm starting with 3 atoms of oxygen, and I'm only ending with 1 atom of oxygen. And that cannot happen. Okay, they have to match each other. So, here's what I'm going to do. I need to think and say, I'm starting with 3 and ending with 2, so what number can I make both of these equal to? Okay, don't think about anything else. Just think about the oxygens. I have a 3 and a 2. What can I make them both equal to? So I can make them both equal to 6. So if I multiply this one by 2, I'll get 6. And if I multiply this one by 3, I get 6. Okay, so that's what I did to this one, and that's what I did to this one. So they match. But now I need to obviously change my equation to reflect this change that we made. So when I'm going to change the equation to fix my problem down here, there's only one thing I can do. So it actually makes it kind of easy because I'm not going to be like manipulating multiple things in this equation. There's only one thing you can do. I can add coefficients. I can add big numbers out front. I cannot add any little subscripts. I can't change this 3 to a 6. Can't do it. Okay, so don't change the compound itself. All we can do is add numbers out front, big coefficients. Okay, so what I did is I multiplied by 2. So that means I'm going to put a big coefficient of 2. Okay, and what that 2 now does is it multiplies in to the O. So 2 times 3, and I have 6 oxygens. Okay, I'm going to do the same thing over here. I have my 2 oxygens, and I need to multiply with a coefficient, big number of 3. So 3 times 2, 6. Okay, sounds pretty easy, right? However, we did cause a problem right here. Now that I have this big coefficient of 2 in this compound, it actually affects everything within this compound. So not only does this 2 multiply over to the oxygen and say 2 times 3 for 6, but it also multiplies to the K and to the I. It's going to affect the entire compound. So by putting this big coefficient here, I now have 2 times, there's no number here, so that means 1. So 2 times 1. I actually now have 2 potassiums. Okay. Same thing with I. I have 2 iodines. Okay. So by putting that big coefficient of 2 out in front of the compound, I affected every single element within that compound. So that means in fixing oxygen, I actually messed up everything else. That's fun, right? It's kind of like a Rubik's Cube. You fix one piece and it messes everything else up, right? So Actually, this ends up being a pretty easy fix, but you really have to watch out for that. Recognize that putting a big number, my coefficient, in front of a compound, it affects everything. So I ended up changing lots of things. So now I'm starting with 1 potassium and I'm starting with 2 potassiums and I'm ending with 1. So to fix that, I'm going to have to multiply it by 2. Okay. And to do that, I put a 2. Big numbers, remember you can only do big coefficients, in front of the K after the arrow. See that I'm trying to change just the products here. So over here, I'm dealing with after the arrow. Okay. So I need to take my potassium and multiply it by 2. Just like that. So that put 2 potassiums as products. So now I'm starting with 2 potassiums and ending with 2 potassiums. But once again, in putting a big number, I have changed everything in this compound. So I have 2 potassiums, but it also made me have 2 iodines. But you'll see that that's actually good. Okay, so this one made me have 2 iodines to start with. And now this one forced me to multiply iodine by 2, but that's good because I started with 2 and I'm ending with 2. Okay? So balancing equations, honestly, I think is a little bit of fun. It's like a puzzle. You just play with both sides until everything works. And the most important thing I can tell you is that you need to keep checking. Did I mess something up? Do I need to fix anything? Okay? So I like to even check when I'm done too. So here I have 2 Ks, and I'm ending with 2 Ks. Perfect. Here I have 2 iodines, and I'm ending with 2 iodines. Wonderful. Here I have 2 times 3 oxygens, which is 6, and I'm ending with 3 times 2 oxygens, which is 6. So 6, 6. Perfect. Everything matches. I have the same number of Ks to start with as I end with, same number of Is to start with as I end with, same number of oxygens to start with as I end with. So I'm done. Okay? Now they normally don't take this long. You are going to get to a point where you don't even need this table. You just kind of check back and forth, 2 Ks, 2 Ks, and it goes a lot faster. Okay, but for now, take your time and check everything. And be wary of, if I change one thing, it affects everything in the compound. Okay, let's try another one. I'll teach you a trick right here. I actually have 2 tricks left to teach you. Oh no, I can't zoom out enough for that. Okay, that's okay. We'll move the board. All right, so here I have a lot of things going on. Now remember, if you have a lowercase, it sticks with the letter in front of it. Okay, so this is Ba, not B and A. It's Ba, barium. Okay, no coefficient, no subscript. That means I just have 1 barium before the arrow. Now be careful, sometimes you need to check, do I have bariums here? I don't. So I just have the 1 barium here. And then chlorine, I have no big number, but I have a little subscript of 2. So it's a 1 times 2. I have 2 chlorines to start with. And then I move on. Na is sodium, stuck together, Na. No number out front, no subscript, so that means there's 1 Na. And then there's 2 things you can do here. You can recognize that this is a polyatomic, if you remember our polyatomics from last semester. So polyatomic ions are elements that are always stuck together in a set way, and we treat them as one group of it's an ion, one group of elements. Okay, so this is called nitrate. You can find it on the periodic table chart that we have attached to Google Classroom. NO3 is called nitrate, has a -1 charge. So I can recognize that this is one thing. This is one NO3. And I can say I have one NO3. Marker's not cooperating. Now, if that's something you didn't recognize, if you didn't look at it and go, nitrate, then you can totally split it up. You can do N and then you can do O. So either way works fine. Leaving it as a group ends up making it go just a little teeny bit faster. But honestly, if that was something you didn't see, you can split them up. You can do BA, CL, NA, N, and O. Okay, that's no problem at all. You can absolutely do that. Okay, so that's everything as my reactants. Then I move on to after the arrow, my products, and I can't zoom out anymore, so we're going to have to kind of go back and forth. Actually, let me just move it in a little bit closer. It's just salt. I'm being salty over here. Ha, I'm funny. All right, so there, now it fits. So looking at my products, I have BA. Again, no number out front, no little subscript. So that means there's one BA. Here's my NO3, and you can see I now have two groups of NO3. That's why it's in the parentheses. That's something we learned last semester. So I have two groups of NO3. So, 2. Again, no coefficient, so I'm just looking at that subscript of 2. And then here I have Na, just 1, because there's no coefficient, no subscript. So 1 Na. And Cl, no subscript, no coefficient. So 1 there as well. Okay? So you'll see I have 2 issues here. I'm good with barium, starting with 1, ending with 1. Perfect. Chlorine, I'm starting with 2 and only ending with 1. That's a problem. Okay, so let's go ahead and fix that. So starting with 2 as my reactants, ending with 1, so I need to multiply my 1 by 2. And to do that, that means I'm going to put a big coefficient, big number out front of 2 times 2. Okay, so 2 chlorines. Now remember, you can never ever put a subscript. Okay, never can you do that. I know that that would make life really easy, but you can't. Okay, only the big coefficients out front. So now this is 2 chlorines. Perfect, wonderful. It did, however, affect my sodiums. It also multiplies into sodium. So you can ignore that and come back to it later, or we can deal with it now. Really doesn't matter. You can go in any order here. So I'm starting with 1 sodium, and now I'm ending with 2. So I need to fix this one by multiplying by 2. Okay, so multiply wherever the sodium is, right here. So I'm going to multiply the sodium by 2 by putting a big 2 out front. Okay, so 2 sodiums. So that fixed sodium. I'm ending with 2 sodiums and starting with 2 sodiums. Perfect. Okay, haven't touched barium. Barium's still good. Fixed chlorine already. Now I'm dealing with the nitrate, the group. Okay, starting with 1 and ending with 2. However, by putting this 2 here, I did influence my nitrates. So I no longer actually am starting with 1. I'm actually starting with 2. Okay, so 2 goes to that whole compound. So I'm going to put the 1 back because that's really what I started with. So it kind of got forced multiplied by 2. But that's wonderful because that's what I ended with. So now I'm starting with 2 nitrates, and I'm ending with 2 nitrates. So this is done. Okay? There's one thing I want to point out really fast. Not terribly important. Okay, Kind of made that ugly, sorry. These ones that don't have a coefficient, like right here, I did not put a number out front. We don't put coefficients if they are ones. So the fact that there's not a coefficient here means that it's a 1. Okay, so I have one compound of BaCl2. I have 2 NaNO3s, and then I end with 1 BaNO3 and 2 salts, NaCl. Okay, so just kind of know that if there's no number, it doesn't mean it's 0. It means it's 1. And we don't write 1s, just like we don't write 1s for the subscripts. Okay, so that's just kind of a trick. If you see these polyatomic ions, you can have them in a group, but you don't have to. Okay, if you think it's easier to split them, you absolutely can do that. So if I was splitting it, when I look at this, I would say I have 2 nitrogens and I have 6 oxygens. Okay, if I was to split that in my chart, if I was to say N and O. Okay, I would have 2 N's and 6 O's to end with. Okay, it just takes a little bit longer if you do it that way. So I like to group them. Okay. All right, so that's the trick for polyatomic ions. Okay, last example. And this one also has a trick to it, so please pay attention because you will come across this occasionally. All right, so here I'm starting with 2 different things. I'm ending with 2 different things, just like we did in the last example. So I'm starting with 2 carbons as my reactants. I'm starting with 6 hydrogens as my reactants. Actually, I guess I should put these further over so I can show y'all how to fix them. And I'm starting with 2 oxygens. Okay. And then after the arrow, my products, I'm starting with 1 carbon. I'm starting with I'm ending with 2 oxygens, but I also have 1 here. Okay, so 2 oxygens here, 1 here, means I'm ending with 3 oxygens. And then I have 2 hydrogens. Okay, so this one is a little bit more difficult simply because I have oxygen in multiple places. So my advice to you, when you see that, an element in multiple places, save it for last. Usually that's going to be the easiest way to do it. Just kind of ignore oxygen completely until the very end. So let's start with carbon, just because, arbitrarily. So I'm starting with 2 carbons, ending with 1. So I'm going to need to multiply that 1 carbon by 2. Okay, multiply it by 2. So now I have 2 carbons, and I'm ending with 2 carbons. Perfect. Now that did impact my oxygens. So if you want, we can change that. Or you can wait and recheck them in the end. It doesn't matter. So here I have 4 oxygens, and then that 1 more. So 5. But again, we're kind of ignoring oxygen for this moment. Starting with 6 hydrogens and ending with 2. Okay, so I need to multiply 2 by something to give me 6. Okay, so that's going to be a 3. 2 times 3 gives me 6. It's a big number. Remember, we can't change the little numbers, only big numbers. So now I'm starting with 6, and I'm ending with 6 hydrogens. Perfect. All right, so that impacted my oxygens as well. Okay, so let's finally take a look at oxygen. We got carbon and hydrogen in line. Let's take a look at oxygen. I didn't impact this, so I still am starting with 2 here. Here I have 2 times 2 oxygens, 4. And then here I have 3 more. Okay, so 7, 4 plus 3. Okay. Now, I'm ending with 7 oxygens. And to start with, I have 2. So what I need to say is, what can I multiply 2 by to give me 7? So this is a very weird and difficult scenario. However, there's a trick. So if you don't know the trick, you're going to struggle with this for a while because you cannot have a half here. Okay? I can't say like 3.5. I can't. Okay? So let me teach you the trick. Otherwise, you would struggle for a bit. So for now, what we are going to do for a very, very short time is say 3.5. Okay? Because 2 times 3.5 does give me 7. So currently it's balanced. I am starting with the same amount that I'm ending with. However, you can't do this, so we need to fix it. Here's the trick. To get rid of a half, I can multiply all of the coefficients by 2. If I double all of my coefficients, it will get rid of this, and it will keep the ratios the same. Okay, I'm not in the end going to change the ratios. So right now the ratios are right. Okay, so you just double everything. So currently I have a 1 here, so 1 times 2 is 2. 3.5 doubled, or times 2, is 7. 2 doubled, 2 times 2, is 4. And then 3 doubled, or 3 times 2, is 6. Okay? So that's just the trick. If you come across one where you're like, what times 2 gives me an odd number, this is what you do. Okay? Put in the decimal, and then double everything. And you'll see that it does work. So let me just kind of erase this because at this point it's going to be way too busy. But let's check. Make sure that everything does indeed match. So I'm starting with 2 times 2 carbons, or 4. Okay. And I'm ending with 4. I'm starting with 6 times 2, or 2 times 6 hydrogens. And then I'm ending with 6 times 2 hydrogens. Okay, so far so good. Oxygen, my troublemaker. 7 times 2, 14. And then oxygen back here, I have 4 times 2, which is 8. And then I have 6 more right here. Okay. So that's just another trick for you to have in your toolbox. You won't see that super often, but that'll save you a lot of time just to know that little trick. So keep that tucked away in your brain toolbox. Okay. So balance it as much as you can. Put in that half number if you're stuck in that situation where that's all you can do. And then you double all of the coefficients. So, 2 most important things I can tell you to sum all of this up is to always keep going back and checking. Always make sure that, like, if I put a number out front, remember that it affects everybody, okay, in the compound. So keep going back and checking. Always check your work when you think you're done. If you think you're done, go back and check them all again. Okay, so that's the most important thing I can tell you. And then the second most important thing I can tell you, they're equally important. They'll tie for first. How about that? You cannot, to balance an equation, you cannot change the subscripts. The little numbers that are attached to the elements have to stay just like that. Okay, so even though it would have been really easy to